Hello, good morning or good afternoon, depending on where you are on the planet joining us today. Welcome to webinar number 2 in our series on product design and manufacturing visualization. You just heard from Chris Murray. My name is Craig Barr, and today we are going to take a look at, in this webinar, we're going to examine the overall process of translating data from CAD software to Unreal Engine. There are certain requirements for data to function properly in an interactive environment. So what we're going to do here today is take a look at geometry preparation, things like managing texture coordinates, and why good UVs are so important for real-time visualizations. We'll also look at the export and import process for data coming over to Unreal and highlight some of the caveats and gotchas you may experience when using certain file formats. Throughout this session, we'll see why designers are choosing the power of Unreal Engine to interactively visualize their designs in really infinite ways. So finally, at the end, we're going to take a look at what's going on with some advanced technology now to help these cross-industry workflows with Unreal Engine. So for today, we want to take a look at the options available for CAD visualization as they exist today, and most of them that have existed for some time now. We'll also take a look at the process of geometry preparation in this idea of data translation, this idea of taking CAD design data and translating it, going through a process, a workflow if you will, and to bring it into Unreal Engine. And we want to look at overall working in Unreal. But for the most part, we really want to get at this kind of in between, this process of getting the data over into Unreal Engine. And of course, we'll look at examples and ideas around Unreal interactive visualization. So I just want to quickly give a shout out to Motus Motorcycles, the fine folks over there. They provided their actual CAD data for this awesome Motus American V4 engine. They like to throw out their precision with an attitude, and it is an awesome piece of machinery. If you want to take a look at more of this, head on over to motusmotorcycles.com. It's a real beast of an engine, and it's a real beauty to be able to work with this data as well. So thanks to the folks at Motus. So let's take a look at our Unreal Engine scene. I'm just going to jump into Unreal here. And you can see I have a pretty simple scene actually set up. So we have our data. Here's our engine. You can see down below we have this content browser, the browser just packed full of all these parts, all these objects that are coming over here into Unreal to allow us to visualize this awesome engine here. And a couple other things that we're going to take a look at is scene organization and some of the complications or intricacies around that when it comes to file translation. So you can see I've got everything really nicely organized here. So it allows us to visualize our data really nicely and rapidly here in Unreal Engine. Let's jump back to the deck over here and take a look at some interactive visualization, right? Some ideas around what's available for CAD visualization options. So we're going to take a look at some of the CAD visualization options available to CAD packages today. So for example, CAD viewport renders, and maybe how the limitations there. Maybe it is actually rendering directly in the viewport or taking screen imagery from the viewport, or also things like built-in rendering, maybe something that's a little more advanced that's built in to be able to render out stills or whatever it is they need to visualize that CAD data directly out of that CAD package. As well, third-party renderers are available to a lot of CAD packages where the data is able to be rendered in things like maybe V-Ray or Corona or other renderers where we can visualize things in those renderers there as well. Of course, visualizing the CAD data is also available through third-party applications. So things like 3ds Max, which we're going to work with here today. Other applications, Cinema 4D, Blender, Maya, whatever it may be, to utilize the power of a third-party 3D content creation tool, for example, to be able to prepare data and therefore render through that different application as well. So CAD rendering. You know, a lot of the things that we see with CAD rendering is sometimes simplified to keep it to what it needs to be, and that is to be able to see the assemblies or the parts as they operate together in their entirety, right? So a lot of things that may visually be very simple, because that is the point of that, is to be able to get that primary message across. Of course, if we want to take that much further, that's where we jump into maybe third-party rendering applications for different scenarios there. As well, when it comes to CAD rendering, we may see simple things like rendering in a third-party application, like in 3ds Max, where we're able to take advantage of either third-party renderers or, for that matter, simple animations, and able to do things like turntables or a simple camera animation, as an example here in Max. What are the limitations that we are working with here in the CAD world? So CAD Visualization Limitations. Some of the typical constraints that we'd see in trying to visualize the data or take the data to another kind of compelling level is, we're typically constrained to things like still imagery, or perhaps, as I mentioned, more simplistic animations, turntables, simple camera moves, things that show off the design rather quickly and in a very simplistic form. So why Unreal Engine for visualization? Let's take a look at that here as to why we want to examine Unreal Engine for visualization. With Unreal, exploring concepts and designs is truly an organic experience. So things like working live in Editor or as a standalone customized interactive application, there are only a few of the possibilities. Keeping designs literally in-hand with mobile on a variety of devices and operating systems, or expanding CAD into a fully immersive virtual or augmented reality experience. CAD is meant to be experienced. There is a distinct difference between viewing and experiencing a design. The individual is in control and is able to achieve experiences unique to that viewer. Of course, creating compelling video edits with Unreal's powerful sequencer editor and beautiful still imagery is fast and easy. When it comes to visualization, designers are clear in their needs. Real-time interactivity is a better way to evaluate and communicate their designs. Unreal Engine really allows for designers to be experienced in new and different ways while allowing for faster iterations and explorations. So let's take a look at some of the data requirements for these workflows, going through from CAD through maybe another application into Unreal. So some of the things that we want to work with here, and I put up here first polygons, right? Simple four-sided quadrangulated faces of a mesh. Well, why am I putting this up here? Well, it's as simple as it is. Here we have a simple quad, four-sided, four vertices representing on each corner. The reason why I'm putting this up here is because this idea of talking about the data translation process between the CAD world and Unreal Engine, and this idea of using another application, for example, like I'm using here today, 3ds Max, why we want to work with certain things. So when I'm talking about these things, I'm actually talking about them in the 3D content creation workflow as well as Unreal. So polygons are something that we're going to see in a moment here as to why it's a good idea to stick with polys if you can when creating assets or changing assets or working with assets in this workflow. Of course, triangles are totally fine as well. This is the simple three-sided face of a mesh. At the end of the day, the engine's going to do a conversion to triangles behind the scene anyways. So we have this thing called n-gons, which is mixed geometry. This isn't necessarily a big deal for Unreal Engine because at the end of the day, it can simply triangulate that. But for a 3D content creation workflow, it's generally not a good idea because you really limit what you can utilize for the tools, or you get into this idea of mixed geometry, which can create problems. And when you get to things like UV layout, that can create problems there as well. So a good idea to avoid n-gons if at all possible. And of course, texture coordinates. These are necessary for working with Unreal into a real-time visualization environment. And we're going to see what that's all about here with UVs as well. So best practices. I mentioned working with quads. Well, why? Quad polygonal modeling allows you to have nice edge flow. So here's a simple image here that describes ways of working with edge flow, and why that's important, and is that it allows us to utilize, better modeling tools. So we have better options when it comes to modeling, more tools built around quad polygonal modeling workflows. That's not to say you can't model or work with triangulated geometry, But you are going to have an easier time working with certain aspects of geometry with modeling tools, as well as when it comes to laying out UVs. Things like being able to access long edge loops and be able to cut and sew seams together are typically easier with a quad polygonal modeling workflow. Now, with that said, that's not always possible, right? But by all means, if you can keep it to a quad-based workflow while you're working, this is going to provide a much easier way to clean up the mesh as well as UV layout and any changes that might want to be needed to be made while working away on the data. You can always convert, right? So working in quads, you can always triangulate that geometry. And of course, behind the scenes there, Unreal is going to triangulate your geometry for you once we bring it over there anyways. So data translation. Let's jump into and take to 3ds Max and take a look at some of the requirements, some of the things we need to consider when we're working with CAD data to bring it over. Working with geometry coming from a CAD package like SolidWorks, we have some challenges related to the overall tessellation or decimation of that geometry to translate this into something that we can deem to be usable within Unreal Engine. So what do I mean by that? Well, here we have all of our components that have been brought over by right into Max from SolidWorks, and let's take a look at a quick example of how we can work with translating this data or decimating it in a couple of different ways here. So I'm just going to turn off, I'm just going to turn off actually the display of the engine on here. Now it's worth noting that I'm going to import in a simple object here. Now 3ds Max of course supports SolidWorks assemblies and parts that can come right over. I have the entire engine in here, and in fact I have actually all the pieces of the actual full motorcycle in here as well. So I just want to find a part here. Here's a simple SolidWorks part that I'm going to bring in. The reason why I'm showing this is that the import settings will give you some very rudimentary, very basic settings in here, but it's important to note a couple of things. So we have this convert to mesh on, the hierarchy mode, so that we can actually use and represent or respect the grouping that existed in the CAD package when it comes over here. And we have this mesh resolution kind of dial bar here. Now this slider is just literally a less or more. That's not really helping us too much in here. So I'm going to just hit import on this. It might take a moment. But what's going to happen is it's going to bring the geometry in, and we'll take a look at this one piece and we'll see how dense that is. And we have to keep in mind that we are dealing with, actually in this case, this motorcycle, a few thousand pieces, right? So we really need to consider the overall polygonal budget, if you will, for the entire project. So here we have our piece. Let's just put on a simple little wireframe override on here. It's actually a lot more dense than I would like this to be. This is a little more dense than we require this to be. If we want to take this into something like an interactive project like VR, or if we really wanted to bring this into a mobile application, we'd really have to decimate this down. Now the challenges, of course, are that we want to represent or respect the fidelity of this, right? So if we go back to our default shading on here, we want to make sure that we maintain the accuracy of this CAD data. This piece of geometry here needs to have the accuracy of the design. So how do we do that? Well, there are a couple good tools here in 3ds Max that we can work with. Just of note, when we're working with poly budgets and things like polygonal counts or vertex counts, in any viewport we can hit 7 in Max, and it's going to show you the overall poly budget. You can see that I've got quite a large number of polygons going on here with all these different parts and different pieces and components of the engine and the overall bike in the scene. So for this particular piece though, I want to decimate this down, or actually translate this into something that's a little more easy to work with. So I'm going to convert it to an editable poly here in Max, and once we have that done and ready to go, what we can actually do is let's jump into our modifier list and grab a Pro Optimizer. Now Pro Optimizer in Max is going to allow us to do a couple of pretty cool things here. So I'm going to hit calculate. What it needs to do, and you'll see it runs through a rather quick calculation, it has to calculate the mesh and begin to build this cache as to what we can work with it or do with it. So I can turn on edged faces for this example here so that we can see it. And we can see all of the geometry in here with this kind of wireframe laid over top. Now what this is going to allow me to do is it's showing a before and after. So you can see that we have about 693,000 faces just on this one part. Now if you put that in the context of thousands of pieces, that's trouble. That's a lot of geometry on there. So what I'm going to do is just start dialing this down. So I'm just clicking and dragging it down. And I can see live in the viewport what's happening. I'm also getting feedback as to how this is being decimated or cached right down into something much lower and workable. So let's actually turn the edged faces off, and we can see that the piece is actually looking really good. We're still maintaining that accuracy, the fidelity of the overall data, while breaking this down to something much lower. So let's put it back into something like wireframe here. And we can see now that we're really starting to lighten up that wireframe quite substantially. And you can see now that we've gone from something like 693,000 faces down to 141,000. So we could certainly take that further. But this really would be a job for, spending the time to make sure that the part still has its accuracy represented. And as you can see here, we're looking quite decent in here, but we'd really want to have other pieces to make sure that they line up and they fit in these holes here, for example. So we've just broken this down here by about almost 90% rather quickly on the vertex count on here and as well as the faces. Now we need to think about this as one piece versus thousands of pieces. To do this one by one over a lot of pieces, that is something to consider for this conversion process. So kind of batch working with decimation is the way to go. The other challenge here, just the last note on this, is that you want to make sure that you're decimating things in a way that it's preserving that accuracy, but also the parts beside it are the accuracy is there as well. So you do have a bit of a challenge in preserving that accuracy and decimating or lowering things down in a way that actually balances out and represents the CAD design properly. Challenges with tessellation and decimation. So as we've seen, we need to work with data or translate that data into a way that's going to be usable depending on what we want to do in Unreal Engine. So we really want to get to this idea of efficiency while preserving accuracy. Well, what do I mean by that? That's this overall mesh fidelity, getting that overall accuracy while staying really light in the scene. Now, again, that depends on what you want to do in the scene. If it is just simple, video editing with sequencer, camera editing, doing different very interactive, cool shots there, or perhaps rendering still imagery, Unreal can handle a lot of data very easily in there. If you want to do something interactive or take it further into things like immersive realities, virtual reality or augmented reality, for example, or you want to work with something like in a mobile application, there are other considerations. Geometry needs to be light. Of course, you need to maintain the accuracy of it. So that's the real challenge there. Knowing where you want to go with your project first is key to being successful in that project as well. So another thing here is maintaining the scale, proportion, and overall volume, of course, when translating or decimating or tessellating the geometry here from its source CAD package. So another thing to consider is if we already had UV data on an object, and if we are retopologizing this object or going through a process of decimation or tessellation, we may lose texture coordinates, maybe not in its entirety, but we may lose pieces of it. So we have to consider that we can get into complications with that. Now, there are ways around that. We can take the original source, higher res, more dense geometry if it has UV coordinates, and we can transfer that UV data onto our newly decimated or tessellated mesh as well quite easily. But quite often we may not have had any UV coordinates there to begin with, so we need to consider how the UV or the texture coordinates are going to be laid out on our new decimated geometry as well. So with that, as mentioned, let's jump back over to 3ds Max, take a look at the Scene Explorer here. We can see that our Scene Explorer here in Max has quite a few components, quite a few pieces in here. So we are dealing with a lot of data, a lot of geometry. Now I'm just scrolling along here on just specifically the engine. Of course, I do have all sorts of different pieces and parts for the entire bike in here. And as you can see, there are quite a few components in there to consider as well while we're working with this data. Okay, so we've taken a look at the Scene Explorer there and 3ds Max and the complications with the number of objects that we're working with. Let's take a look at now UVs. We looked at this idea of geometry translation and decimation, and we need to look at UVs. Well, the best place to start with this is asking the simple question, what are UVs? UVs, in essence, are a coordinate system to place textures, right? So it really is a two-dimensional unwrapping of a model surface. So this idea of flattening out a texture coordinate system, right? So think of taking a 3D object, unwrapping it, making it into a flat 2D image-based coordinate system that allows us to place texture data on that. So this allows us for that simple placement of texture data and as well editing of texture data in 2D image editing applications, for example, Photoshop. And this is necessary for any operation involving baking. And we're going to see what that is involved with when it comes to Unreal Engine as well. Baking can be anything related to specific texture data, but in this case, what we're going to look at in Unreal Engine is, excuse me, this idea of light baking or creating light maps that really grabs some of that light data or all that light data, and we can utilize this in a real-time environment. And we'll look at what that's about and why we work that way in Unreal Engine here shortly as well. So this process of UVs, how does it work? Well, here's a simple illustration here. You know, we have a simple cube and this idea of unfolding this or unwrapping it, or maybe a simpler way to look at it here is in this checkered pattern down below where we are just simply, essentially unfolding and flattening this out into something that allows us to place texture detail onto a flattened, opened, unwrapped, this idea of a pelted version of the 3D mesh to place that texture detail on there. So an overview of UVs. Now, there are a couple different processes here that we're going to take a look at in how we can address this here in 3ds Max as an example. Automatic UVs. Now, automatic UVs are very quick, but they're limited. This is the process of having the software or the tool actually apply UVs automatically for you. We'll look at the limitations in that. Now, manual UVs really are the better way in the sense that you have the control over the accuracy of where you're placing that UV data for your texture info. Now, this is necessary for hero objects. So, auto UVs, as quick and convenient and as good as some of them are today, don't necessarily provide for what is required for hero objects. And what I mean by that is anything that you need to see up close to the camera, or anything that has specific texture detail, logos or badges, for example, on there that really need to be placed in a specific way. There are many great tool sets available today for working with UVs, and we're going to look at some of the workflow here in 3ds Max. So let's hop over to 3ds Max and take a look at this idea of working with UVs. And in 3ds Max, we can address any kind of issues related to texture coordinates. Actually, quite simply, there's some great tools here in Max that will allow us to work with UVs quite simply. So if we have our engine data here, I'm going to just grab a simple object, perhaps this guy here, and I'll just zoom in on that. What I want to do is use this as an example of different ways that we can work with UVs rather quickly within 3ds Max here as an example. So the first thing I want to do, I'm just going to do a quick, I'm going to convert this over to an editable poly, and I'm going to drop down on here a simple little unwrap UVW, and I'll jump in there and we'll work with the poly faces on there. Now if we open up the UV editor, what you're going to see here is that we do have some UVs on here. And in this case, something like this is, an automatic UV layout. This is essentially just an automated kind of computed or calculated UV layout for us here. Now, this might work for what we need, but there are a couple of cases that it's not going to work. So if we need to make sure our light maps are going to be clean, we could have issues with this layout here. There are some pieces that are very small, and we have a lot of pieces. So that can tend to lead to, some Lightmap issues, maybe with a bunch of different seams that we may see on the object. But if we wanted to place a texture map on this object, so I'm just going to change this to something like this little checkered pattern with letters and numbers on it, we can see in the viewport, if I kind of tumble around here a bit, there are a lot of seams there. Nothing's lining up, nothing's flowing. So, maybe a simple example for this, if we wanted to put something like a special steel map or a brushed aluminum, for example, texture map on there, that's going to, it's not going to look right. We're going to have a bit of an issue on that. So how can we fix that? Well, first of all, before we jump into how we could fix that, I just want to show quickly that if we wanted to create our own automatic mapping, it's as simple as dropping down something like an unwrap UVW, hitting flatten mapping, and we just literally hit OK on that. Now, if we wanted to work with maybe some bigger or fewer pieces on there, we can increase this polygon angle threshold and start to work with fewer pieces or larger pieces, and that's how we can get that automatic UV layout. Now, it's important to understand that I'm going to show here, areas that this wouldn't work, but there are cases where automatic UVs are going to get you there. Sometimes there are objects that are not texture-based, and the light maps for what you need them to be, this may work out perfectly fine. And if you have, objects that are going to be a specific material, for example, something like an automatic UV layout like this may work just completely fine for what you need. And you saw how quick that is. I just drop down a modifier and simply do a flatten map and hit OK on that, and we can get results that'll get us there rather quickly. Now, if this was a hero asset here and we needed to put a specific texture map on there, like I mentioned, what we'd want to do is put down a specific projection. So in this case here, being the shape of this being cylindrical, I'll just throw down a simple little cylindrical map on here. And what we can do with this is, let me actually select all of these faces in here and just put in some simple normal mapping on there. And we can see that I'm just editing overall this piece in here. So once I have kind of the something that looks decent, I have a top up here and I have a bottom, just rather quickly, that's not bad. So I'm just going to kill the projection on there and then grab our actual texture map and just kind of fit it into place in here. Now I'm doing this quite quickly here just to illustrate the difference. Now, if we click back into the viewport, you're going to see here now that we have something that represents that texture map actually quite well. And I could come back in here and begin to edit this further if need be and work with the overall scale of things in here, something like that. And you can see now that we have a texture map that actually flows, much like what we see in here. We see the edges of the grids, the colors and the numbers and the letters, and this would work fine with a texture map that we could wrap around there. Something like that brushed aluminum, for example. So that's a quick overview of how we can work with UVs here in 3ds Max. Let's take a look at how UVs work with Unreal, and there are a couple things to consider. The basics. What are UVs needed for when we come into Unreal Engine? Well, we looked at the idea of texture maps, right? Diffuse maps or color maps for that matter. Maybe things like bump or normal maps or any kind of displacement that we might want. That kind of visual basis of image-based textures on there. But we have this other world of light maps, and this is the second channel that is required. If you're going to take advantage of Unreal's lighting abilities, you're going to need good UVs to have good light maps. And we'll see what this light map system's all about here in Unreal. So UVs, at the end of the day, are needed for every poly or tri face of a mesh. So every mesh needs to have its own UV set if we want that to display properly, especially when it comes to baking lights or creating those light maps. So as an example with Unreal and UVs, specifically when we get into manual UV layout, we look at these ideas of textures, anything with a logo or a badge on it, this kind of hero asset of things that needs to be applied directly to a surface, as opposed to a large object without any specific texture hero imagery on it that can be rather easily automatically laid out when it comes to UVs. All right, so we've mentioned this term Lightmap. Well, what is a Lightmap? A Lightmap is a texture that stores light data. That's as simple as I can put that right now. It is simply a texture map that stores light data. Now, as we'll see shortly, they look different. They have a different look to them, and they operate in a different way as well. So they're a very efficient method of providing lighting at low computational cost. So another way to look at this is rather than have a scene full of actual lights, with dynamic lighting where it's working in real time and dynamic shadowing that's actually happening in real time from an object, we're able to light a scene, take all of that lighting data, bake it into images, and essentially do kind of a multiplication or an overlay process that'll allow us to have a scene without the cost of lights, but we're getting that same quality of lighting that we expect when we bake it or calculate it out. So Lightmass is the overall baking engine to produce light maps. So in Unreal, we're going to look at Lightmass and how that works. And Lightmass is this behind-the-scenes engine that actually calculates the lighting and creates texture maps, or light maps for that matter, out of that system of baking based on the lighting in the scene, and of course that all essential UV layout for how your light maps will be created. Behind the scenes there is Swarm Agent, and Swarm Agent processes the light mass calculation. So you have light maps which are produced by Lightmass, and Swarm Agent is this very cool, essentially node-based distributable render farm. You can think of Swarm Agent as a render farm in itself where we can actually render out light maps quite quickly. So let's jump into Unreal and take a look at Lightmass and light maps with this scene. So light maps and Lightmass and the Swarm Agent in Unreal Engine. Well, what is that all about? Well, here's the basics of it really quickly. So we have under here this build button, and you'll see build lighting only, lighting quality, and even lighting info into this. Well, here's where we can take a look at our light map density rendering options. So you can take a look at a maximum density, ideal density. You can change the overall resolution to kind of a minimum and maximum for all of the static meshes in your scene. As well, we have lighting quality here. I have mine currently set to high for this demo right now. And then what would happen is that if we hit build lighting quality, and we'll do that in a second, what's going to happen is we're going to have a process of baking out lights, or baking the lighting data into essentially a texture map, something that is actually going to take that data and be able to make it portable, or at least something that will represent lights to make our scene more efficient, so we don't have to use real dynamic lighting or real dynamic shadows in there. And here underneath the world settings, if we come in, we can see all of our light mass settings in here to help us with the overall quality of that light baking process. Now here's some of the maps that actually come out of there. I'll just let's just find something that looks a little interesting here, and we'll double click on it. And we can see this very strange, hues and colors. This is the light map. This is what Lightmass has produced for us, and it's actually created this data in here that it will store all of that lighting data at a resolution that it requires to be able to bake in that data, or be able to represent that data at runtime within our application here, so that we are saving on the overall computational data by reading in texture maps essentially, or images representing lighting data. Now let's take a look at the Swarm Agent here. So if we go up and we hit build lighting only, so we go ahead and we hit that, what's going to happen is that the light mass is going to fire up, and we're going to get this Swarm Agent happening. The very cool thing about Swarm Agent is that this is distributable. So this actually works much like a render farm. So if you have access to, some nice, a big render farm, or some really nice high-end workstations or high-end hardware and GPUs, things like what HP builds, or the awesome GPUs that AMD is building these days, if you have access to a farm like that, you can actually take advantage of that and distribute essentially like a render farm to be able to rapidly bake out, or essentially build all of your light map data. So Unreal and UVs, I just want to summarize here, as simple as this is. This is key though. Simply put, bad UVs, you're going to get bad textures. And if you have bad UVs and bad textures, you're going to end up with bad light maps. So really what we need to go for, as simple as it is good UVs overall, which is going to be good textures and resulting in good light maps. Without that, we are going to see something very noticeable, and it's important to understand this world of live, real-time interactivity. What you see is what you get. So this is why I keep driving home the importance of UVs or good textures and good light maps. So here's an example. Bad UVs, this automatic versus manual. Here we have a simple tire here in the scene. And we can see up here on this corner that we don't have very good texture details. Something's going on in there. And there's also a seam, which is probably from the Lightmap baking because of the bad UVs laid down in here. Now this tire is laid out using automatic UVs. As we can see on the right with these UVs laid out here, you can see the faces of them are scattered out quite randomly. And this isn't going to result in a good texture placement. To compare, here's good UVs, this idea of manual layout. So we've seen that automatic UV layout, and now we have a manual layout here. So you can see on the left we have some nice texture detail happening along that sidewall of that tire, and that texture is how it should be rather than just scattered around. And we're not seeing seams from the light maps, and that's because this has been manually laid out. So projected in a specific way, you can see the rest of the rubber detail from the tire is laid out to be able to grab that texture detail very easily as well. So traditional data export to Unreal. This is a nice little chart that I've put together here just to look at supported 3D file formats for Unreal and 3D content creation workflows. So typically you'll see things like OBJ. Now OBJ has been around a long time. It simply stores polygons and also UVs, but that's about it. We don't get any camera data, light data, any kind of rigs or IK. Animation and deformations are limited to writing out an OBJ file per frame. So that's something that's not going to work well in a real-time interactive environment. So we typically avoid that unless it's for a specific object for maybe a specific need. But what you will commonly see is the FBX format or .fbx. Now, just to summarize that, it does support polys and NURBS to a certain degree. You'll notice that I have highlighted in orange things that we aren't going to be working with necessarily in Unreal. It also supports UVs, cameras, lights to a certain degree, rigs and IK again to a certain degree, animation, deformation, all these things to a certain degree, but you see a lot more than what OBJ format supports. It does support basic materials, of course textures, and it is a nice workflow between 3D content creation packages and Unreal to a certain degree. We're going to see the limitations of that shortly. There's another format, Alembic, which Unreal supports. Right now it's in a bit of a beta form, but you can use Alembic. It's a .abc format. You can bring over geometry, UVs, cameras to a certain degree, lights to a certain degree, and that's basically about it. Now, the cool thing about Alembic is that you can bring over animation and deformations baked. So it will use this caching system where you could actually bake, or cache out a cloth simulation, for example, and be able to bring that over as an Alembic file format. But typically, FBX is what you're going to see mostly used between 3D content creation applications and Unreal. So considerations, exporting to Unreal. Typically what we want to see is this ability to place our objects in a scene quite easily without losing their placement in there. So we need to consider that each object is snapped or placed with its origin at the world origin. And if we do that, it makes it easier to bring all of that data over to Unreal Engine. Rather than each object having its own individual origin, they'll know their place or their position in space there. Now, basic materials with some connections is a bit of a limitation here that we're dealing with when we work with things like FBX. We can have basic materials come over, but if we're doing anything more complex, maybe a different type of material network or something for a different render workflow, we are going to lose those connections when they come into Unreal to a certain degree. There's been some advancements lately that are helping that process along as well. So some positional data for certain lights will come over through FBX, but we may lose a lot of the lighting detail. In fact, the entire light might be gone as well. So simple lights may translate, but if there is something more complex going on, we are just going to be left with essentially the positional data of where those lights live. And basic cameras. Anything related to specific camera lensing or anything more complex on a camera is going to be lost in there as well. So limitations, traditional data export for Unreal. We lose our hierarchies. We lose our scene organization. That's a problem. When we get to dealing with CAD data, as we've seen, when it can be objects in the thousands, we want to be able to have that ability to have our scene organized. We want those hierarchies and those groupings. We lose layers if we're working with something like layers. We lose those. They don't come over in FBX translation. As I mentioned, we lose, certain light data. If you're working with profiles like IES profiles, that connection will be lost. Unreal supports those profiles, but that connection will be lost. So that's important to understand. This idea of what I'm referring to here is that you have a package, a 3D content creation package, for example, and then you have Unreal Engine, and we have in between this file format, say for example FBX, that can become the limiter between the two packages. So we really need to look at ways, kind of be aware of these gotchas when working in these traditional data export workflows here as well. So third-party plugin data. This could be even an example where an application like 3ds Max supports it and Unreal supports it, but the FBX plugin format between does not. So we lose that data in translation, literally lost in translation of moving the data back and forth. And of course, if you're working with things like instances, formats like FBX will lose those, and you've lost out on your instances coming over. So how do we work with this in Unreal Engine? Well, we can look at importing data here. So when we import the data into Unreal, working with something traditional like FBX, we're working with a lot of files. They can be big files, and the importing can be very slow. And as I mentioned, with hierarchies, grouping, any kind of scene organization, we're dealing with a loss of organizational structure. Materials, again, need to be reconsidered quite often unless it's a simple basic material coming over. And fixes and adjustments can be time-consuming with large files. So if I need to fix something that doesn't look right in Unreal, say for example with UVs, it can be time-consuming where I may have to re-export the entire file to bring it back over to Unreal if I'm relying on something like FBX, depending on what that CAD data is. So I could risk loss of potential data of components if I'm moving back and forth with this. So we do want something that's going to be able to keep a better control on that, and you definitely want to keep that in consideration if you're relying on something like FBX as your data translator. Let's jump into Max here and take a look at the FBX export options as they exist. So we're back over in Max here, and just quickly to look at some export options related to FBX. Now, there are a couple basic things that we can do. We have this entire engine here, and I've actually got this into a group here that I can work with. So if I want to export this entire engine as one group, I can simply select the entire thing if I wanted to do that, and then go down to our export selected. And you can see I have a file here. I'm just going to simply put in Motus Engine. And if we hit save on this, we're going to get the FBX options. Now, by default, it uses this media entertainment option, and that typically is pretty decent and will do what you need to do. There are some considerations here with geometry, however. If you're doing anything specific, if we used any of the modeling tools here in Max, perhaps use something like a turbo smooth or any kind of smoothing, or doing anything with the normals on the surface, we may want to toggle on smoothing groups for our exporting the geometry. We don't have any animation any specific animation going on in this scene in here, so we don't necessarily have to worry about that here. But cameras, of course, if we have anything specific going on the cameras, we're going to lose a lot of that data. So some of the basic things on cameras will come over, mostly positional data to be concerned with. So same with lights. If we're doing anything overly complex with the lights or anything like that, we're certainly not going to be able to translate all of that light data. If we have anything specific going on the light data or any other kind of plugins or anything, we may just end up with simple positional data as to where those lights live in the scene. So some considerations for if you were in that, going to bring that over. Now, embedded media, if we turn that on, if we have textures in the scene, we can essentially package everything up and transport that over very easily. It's best practice to actually not use that. Keep your textures separate. And if you're using basic material hookups, FBX will respect that and remember those hookups and actually do that for you as well. Now, we looked at this idea of grabbing an entire giant object like this and exporting it all together. What we can also look at doing here, if I just open up that group, if we wanted to export specific parts, we can certainly, of course, do that same process by doing the export selected. We can also, if we needed to have specific parts by shift selecting together, we can do this. Now, the reason why I'm talking about this or mentioning this is that there are some considerations here. There's a lot of data here. In the scene, we have thousands of parts. So the data can get quite large, but that's not necessarily a huge deal for Unreal Engine to deal with. But if we need to do some fixes, maybe you need to repair the geometry or address the decimation on the geometry or fix a UV map, for example, and you need one part to come back. If you've sent everything as one giant FBX file and you need to fix one part, you could get into issues back and forth with things like losing the positional data, for example, on an FBX file. And of course, exporting everything one by one can be quite time consuming as well. So I wanted to just show here we have all of the FBX components of this engine here. And it's worth noting that we're at, about 2,700 parts for this. This is the engine and the bike in here. So lots of data, lots of data to consider for shipping back and forth between our CAD package, Max, and from Max to Unreal. So FBX as a translator can do some of the basic things that we need, but there are lots of considerations for things like positional data, the number of objects that we're translating, UVs, decimation, any fixes back and forth that we need to do. You need to keep things like this in mind for that overall data translation into Unreal. Now that brings us to Datasmith. Well, Datasmith. What is Datasmith? Well, this is the aim of Datasmith is to make this overall exporting and importing process that much easier. So let's take a look at Datasmith exporting from 3ds Max, or at least the options there, and over here in Unreal what the options are as well. Okay, we're here in 3ds Max, and what we want to do is export this, taking advantage of Datasmith and what it brings to our workflow here. So I'm going to go to Export Selected, make sure that I have my Unreal plugin selected here, my Datasmith plugin, and then just bring it over here, and you can see that I actually have one already set here, and this is the MSTR, which is the Motus, the actual motorcycle that I want to save over. So I would go ahead and hit save, and what you're going to see is that we get some export properties that are very important here. Things like by default, the exporting the geometry, materials, textures, for example, are already turned on. This here, create UV2 channel. Now this is when we were talking about light maps. If there isn't that second channel created, which typically if you're just creating a texture channel, you might only have the one UV channel, this will take care of that for you. It's going to go ahead and create a second channel for you to help you with that light map process in there. As well, things like texture resolution size. Well, you can see we can go all the way up to 16K on that, so it's quite large. And applying a texture resizing. Unreal Engine prefers things to the as close to the power of 2 as possible for textures. For example, 4096 by 4096. It's a much more efficient calculation when it comes to texture mapping. So we could go ahead and simply hit OK. I'm not going to on that because I have this here. But I'm going to jump over to Unreal Engine where we have our engine and just, or actually into a blank file here where we have nothing, and we can take a look at that import into here. And you can see that we get a kind of a similar processor. So I'll select our file and we get an importer menu where we have quite a bit of the same assets or attributes promoted that we saw on the export here. And things like materials, either keeping the materials that exist or replacing them. And then we could go ahead and import that in. And of course, I'm not going to do that here because I happen to have this file. Just switch back over to this guy. And we can see now some important things. We have our scene, and we have a bunch of folders here all set up, ready to go with everything categorized and organized. So we have our scene organization happening, and we have our data coming over looking really nice. And we're able to take advantage of Unreal Engine without having to worry as much about that whole data translation process because we have a nice kind of, so far it's building towards this one-stop shop idea of this aim to make life so much easier for you for translating CAD data into Unreal Engine. And as mentioned, this is a beta project. Certainly check it out. Lots of very cool things going on with Datasmith. So a traditional CAD to Unreal Engine workflow, to summarize what we're talking about here today, we have this ability to work with our CAD data, but as you've seen this workflow, this idea of taking CAD data, exporting it, bringing it to another package, to clean it up, to add things like UVs or work with UVs, to organize the content, convert it, tessellate it, export it again, bring it over into Unreal Engine, maybe have to reorganize it again, and potentially rebuild the scene or build a new scene. There's a lot of steps there to work with CAD data to Unreal Engine. So there's a lot of considerations here, a lot of things at stake in translating that data properly from a CAD package into Unreal Engine. The goal of things like Datasmith is to eliminate a lot of the problems associated with this. So we can look at this idea of getting rid of a lot of those issues there and really aiming towards, working towards something that is much more organic and fluid. The idea of being able to take CAD data and eliminate a lot of those steps to have the accuracy, the fidelity of that design, and the positional data, the scale, everything that we have there. And if we've taken it further and hooked up maybe a little bit more complex materials or some lighting or maybe some camera work, and to be able to translate this data into Unreal Engine much more efficiently and effectively. As you've seen here, a lot of the time considerations here, a lot of the time consumption in this workflow is in that data translation process, things like UVs, a lot of things to consider to take our CAD designs from one area and be able to see them live in Unreal Engine. So with things like Datasmith, it is making that world that much more easier, that much more powerful, and that much more simplistic to visualize your CAD designs in Unreal Engine. So I want to thank you for joining us today for this webinar on product design and manufacturing visualization. I want to thank HP and AMD for allowing us to put these webinars on. And of course, the fine folks over at Motus for your beautiful motorcycle design and your CAD data. Thanks for joining us today, guys. I hope you enjoyed it.